Binomial theorem. In our previous classes, we have studied what are the different algebraic expressions where you have one term, maybe two terms, three, and there are many more terms. And so also you have studied with different degrees, maybe a linear, maybe a quadratic, cubic, and so on, right? In this chapter, that is binomial theorem, we will be looking at only binomials. Now, what are these binomials? Algebraic expressions having only two terms can be defined as a binomial, right? So if I write here x plus y, this x plus y is a binomial. Why? Because x and y, there are only two terms. So if there are two terms, we call it by the name a binomial. Now, in this section or binomial theorem, we won't be just looking at x plus y, but we will be looking at the powers of x plus y. So what are the different powers of x plus y? I can say that x plus y the whole raised to 0 is nothing but 1. And now if I take x plus y the whole raised to 1, that is nothing but x plus y. And x plus y the whole square, which is nothing but x square plus 2xy plus y square. These all expressions we have studied in our previous classes. And x plus y the whole raised to 3 will be x cube plus 3x square y plus 3xy square plus y cube. So these are the different algebraic expressions that we have over here, which was a binomial, and then we took a power, we raised it to the power of 0, we got 1, we raised it to the power 1, we got x plus y, then 2, then 3, and so on. Now, if I do this continuously, suppose if I'm asking you what is x plus y the whole raised to 4, do we know that directly? Till x plus y the whole cube we all have studied in 8th and 9th, right? But when it comes to x plus y the whole raised to 4, we have not used it much. If you have used it before, then you could remember it, but not x plus y the whole raised to 4. So what happens when it is asked x plus y the whole raised to 4? How can you write x plus y the whole raised to 4? I can either write x plus y the whole raised to 4 as x plus y the whole square into x plus y the whole square, yes, or can I also write as x plus y into x plus y the whole raised to 3, yes. So these are different ways I can write x plus y the whole raised to 4. Now let's try to find out what is x plus y the whole raised to 4. So using the expansion x plus y the whole raised to 4, which is x plus y into x plus y the whole cube. What is x plus y into x plus y the whole cube? X plus y the whole cube is x cube plus 3x square y plus 3xy square plus y cube. So if you multiply that, you will be getting x raised to 4 plus 3x cube y plus 3x square y square plus xy cube. Then you have plus x cube y plus 3x square y square plus 3xy cube plus y raised to 4. And now if I add the like terms, I will be getting x raised to 4 plus 3x cube y plus x cube y, that will be 4x cube y plus 3x square y square plus 3x square y square, that will be 6x square y square plus xy cube plus 3xy cube will be 4xy cube plus the last term is y raised to 4. So you have the expansion of x plus y the whole raised to 4. Now, if I do multiplication like this for x plus y the whole raised to 5, suppose if I take x plus y the whole raised to 5 and write it as x plus y the whole square into x plus y the whole cube, I can find out. And also x plus y the whole raised to 8, maybe I can write it as x plus y the whole raised to 4 into x plus y the whole raised to 4, because now I have x plus y the whole raised to 4, I can use that and find out x plus y the whole raised to 8. But is this multiplication always possible? Is it going to take a very less time or a very huge amount of time? Of course, it will be taking a very huge amount of our time. So using binomial theorem, now we can always simplify these things. But before going into that, if I multiply this one, x plus y the whole raised to 8, how much amount of time will I be taking, or how much amount of time will I be wasting for that? Very huge amount of time. To reduce that whole step of multiplication, Pascal, that Blaise Pascal, he came up with the idea of Pascal's triangles. So let's first look at what is this Pascal's triangle. So in Pascal's triangle, I'll be drawing some numbers over here. So I have a 1, then 1 over here, 1 on both sides, another 1 over here, yes, another 1 on the sides, another 1, another 1, another 1. So like that. And now the first row, let it go like that. Second row, 1 plus 1 and 1. Third row, add these two 1 and 1. So when I add these two 1 and 1, I will be getting 2. So this one over here 2. And now in this row, what do you have to do? Add 1 and 2 together. So you'll be getting 3. This 2 and 1 together, you'll be getting another 3. And then in the next row, add this 1 and 3, 4. 3 and 3, 6. 3 and 1, 4. So you will be having like this. And the next one, add 1 and 4, you will be getting 5. 4 and 6, you will be getting 10. 6 and 4, again 10. 4 and 1, 5. So you get like this. And now in the last one, not the last one, but here in this triangle, I am drawing the last one. So you'll be getting 6, 15, 20, 15, 6 and 1. So these are the different numbers that you get here in this triangle. Is there a triangle which is formed over here? If I connect all these things, am I going to get a triangle? Yeah, it almost is looking like a triangle. Yes, it is. So this triangle whose sides are all made up of 1. The sides are all made up of 1, right? You can see that all the sides are made up of 1. And now inside those ones, you have different numbers. 2, then 3, 3, then 4, 6, 4, then 5, 10, 10, 5, then like that 6, 15, 20, 15, 6, like that. So you have different numbers. Now what are these numbers got to do with our binomial theorem? And what is Blaise-Pascal helping us? Now let's look at that. So what is x plus y the whole raised to 4? X plus y the whole raised to 0. You know that it is equal to 1. X plus y the whole raised to 1. It is equal to x plus y. X plus y the whole square. What is x plus y the whole square? It is nothing but x square plus 2xy plus y square. Now what is x plus y the whole cube? It is nothing but x cube plus 3x square y plus 3xy square plus y cube. And what is x plus y the whole raised to 4? We learned it before, x raised to 4 plus 4x cube y plus 6x square y square plus 4xy cube plus y raised to 4. So this is x plus y the whole raised to 4. Now these are the different expansions that we just looked. Now what this expansion has got to do with Pascal's triangle? Look, for the first one, you have x plus y the whole raised to 0, which is 1, and this is that 1. X plus y the whole raised to 1 is x plus y, and look at the coefficients of x and y. 1, 1. So that is this 1 and this one over here. Got it? So that is how this Pascal's triangle is related to binomial theorem. Now x plus y the whole raised to 2, x square coefficient 1, 2xy coefficient 2, y square coefficient 1, that is 1, 2, 1. Clear? X cube, that is x plus y the whole cube, x cube 1 coefficient, 3 coefficient 3, and there is another one 1, 3, 3, 1. So this Pascal's triangle is giving us the coefficients of our binomial expansion. So what is this Pascal triangle giving us? The coefficients of binomial expansions. Very important, the coefficients of binomial expansion, which is 1, then we have 1, 1, then we have 1, 2, 1, then we have 1, 3, 3, 1, and then we have 1, 4, 6, 4, 1, which is over here, which is the coefficients of the expansion x plus y the whole raised to 4. Now this will help us to find out expansions of larger numbers. Suppose if I am taking the expansion x plus y the whole raised to 6. Now the fourth power is having this one coefficient. So the fifth power will be having this one as a coefficient, and the sixth one will be having this as a coefficient. So if I take the coefficients, I will be getting 1, 6, 15, 20, 15, 6 and 1. Now I only have the coefficients, I don't have all the numbers, right? So when you look at the numbers, you have all this as a coefficients. Now what are the terms which should be coming inside? Just look at x plus y the whole raised to 4. The first term is x raised to 4. X is having a maximum power there, 4. Then coming to the next one, x raised to 3. The power is decreasing by 1. Then it comes to the next term, x square, again decreases by 1. Then it comes as x, decreased by 1. And then the last term, which does not have a power of x, that means x power is 0. So the power of x is decreasing. Yes. So in a binomial expansion, the power of x decreases. The power of x decreases. And what happens to the power of y? You can see that in the first term there is no y term. So that means the power is 0. The second one, y is having a power 1. then 2, then 3, then 4. So you can say that the y power is increasing. This was in the case of x plus y the whole raised to 4. Now we are taking x plus y the whole raised to 6. So what will be the power, the highest first one? It will be x raised to 6, and then you have one power which is decreased, x raised to 5. Along with that, there is a y which is increasing. And then again, x raised to 4, y power is increasing, x square. Then you have x raised to 3, y power is increasing, y cube. Then you have x square, y raised to 4. Then you have x, y raised to 5. And the last one, you have y raised to 6. Now put all a plus in between and you get the expansion for which one? X plus y the whole raised to 6, which is using what? The Pascal's triangle. But this is not all about binomial theorem. When it comes to higher powers, maybe 8, 9, 10, maybe 20, this Pascal's triangle, finding out the coefficients will itself take another good amount of time. So that means every time you cannot use Pascal's triangle, also you cannot rely on that. You need another easier way, which our binomial theorem will help. So binomial theorem will help in that. Now what is this binomial theorem and how is it going to help us? So according to the binomial theorem, it says that a plus b the whole raised to n can be written as sigma r equal to 0 to n, a raised to n minus r, b raised to r. So this is how you write the expansion. What is all this? A plus b the whole raised to n. Then also don't forget to put NCR. So it is not a raised to n minus r, it is NCR, a raised to n minus r, b raised to r. Now this is our binomial theorem. And what is this all NCR and all these things? So instead of using Pascal's triangle, which tool is going to help us? Combination is going to help us. So combination is helping us in the way of NCR. What is NCR? N factorial by n minus r the whole factorial into r factorial. This is NCR. So if I use this combination as a tool inside this, I get a theorem which is saying a plus b the whole raised to n is sigma r equal to 0 to n NCR a raised to n minus r, b raised to r. So let's look at how can we find out an expansion using this one. Let's look at a plus b the whole raised to 3 itself. So if I see here it is 3, that is n is equal to 3. So the first term will be 3c0 a raised to 3 minus 0 r raised to 0. Sorry, not r raised to 0, b raised to 0. Plus the next term, r is starting from 0, then it goes from 1, 2 and finally ends at 3 because r equal to 0, then it ends at what? N. So the next term will be 3c1 a raised to 3 minus 1 b raised to 1. The next term 3c2 a raised to 3 minus 2 b raised to 2. And the last term is 3c3 a raised to 3 minus 3 b raised to 3. And when you do all the calculation, 3c0 is 1 and you have a raised to 3 plus 3c1 is 3, you have a raised to 3 minus 1 a square and then you have b raised to 1 b plus the next one 3c2 is again 3, a raised to 3 minus 2 is a, then you have b raised to 2 plus 3c3 is 1, a raised to 3 minus 3 is 1, b raised to 3. So this is a raised to 3 plus 3a square b plus 3ab square plus b raised to 3, which gives us the expansion of a plus b the whole raised to 3. So understood how using binomial theorem, using a simple tool of combination, we integrated that tool along with the formula and we got a theorem which states that a plus b the whole raised to n can be written as sigma r is equal to 0 to n. What is this r equal to 0 to n? R starts from 0 and ends at the highest power which the expansion takes, that is n. So r equal to 0 to n, NCR, you use combinations, NCR, a raised to n minus r, b raised to r. Put all that inside this, you get the expansion of anything. You put any number here, any integer, you get the exact value for that particular binomial expansion. Hope you understood that. Now let's just find out what is x plus y the whole raised to 8. What will be x plus y the whole raised to 8 using the formula? It will be 8c0, not a raised to 0, it is x. So x raised to 8 minus 0 y raised to 0 plus 8c1 x raised to 8 minus 1 y raised to 1 plus 8c2 x raised to 8 minus 2 y raised to 2 plus 8c3 x raised to 8 minus 3 y raised to 3 plus 8c4 x raised to 8 minus 4 y raised to 4 plus 8c5 x raised to 8 minus 5 y raised to 5 plus 8c6 x raised to 8 minus 6 y raised to 6 plus 8c7 x raised to 8 minus 7 y raised to 7 plus the last term is 8c8 x raised to 8 minus 8 y raised to 8. So using all this, find the value of the 8c0s, 8c1, 8c2, 8c3, putting all these coefficients, and finally you will be getting the expansion. Now writing the expansion will take a very good amount of time also to calculate all this. So do calculate all these things and you get the exact expansion for x plus y the whole raised to 8. Now what happens when it is x plus, instead of x plus y, if I am writing x minus y the whole raised to 4. What is x minus y the whole raised to 4? X minus all the whole raised to 4 will be x raised to 4, 4x cube y, 6x square y square, then again 4xy cube, then last term is y raised to 4. But, why this but? You can say that since it is x minus y, since it is the expansion of x minus y, it won't be having all positive terms. There will be alternate positive and negative. So the first term will be positive, second term will be negative, third term will be positive, the fourth will be negative, and the last term will be positive. So this gives us the expansion of what? X minus y the whole raised to 4. So x minus y the whole raised to 4 is x raised to 4 minus 4x cube y plus 6x square y square minus 4xy cube plus y raised to 4. And that is the expansion of x minus y the whole raised to 4. And how we can write that as a general term? So a minus b the whole raised to n can be written as same as sigma r equal to 0 to n ncr a raised to n minus r, b raised to r. So if I simply write a minus b the whole raised to n also like this, that is not the right answer. So what happens? Since there is an alternate negative and positive terms, you have to put a minus 1 raised to n inside. So what happens to the formula? Inside the formula, you have to put sigma r equal to 0 to n, then put minus 1 raised to n also inside. And that minus 1 raised to n will find out which are the terms which are positive and which are the terms that are negative in a binomial theorem. Also look at if there is a power 4, the total number of terms is 1, 2, 3, 4, 5. So that is 5. So if n is the power, the number of terms will be how much? N plus 1. Also remember that. So in this session, we have discussed all the basics of binomial expansions, starting from what is a monomial, binomial, trinomial, and all these things. And then we discussed Pascal's triangle, and also we finally discussed what is the exact theorem also. And we have done some expansions also using those theorems. More about binomial theorem you will be learning in the next session. For the time being, let's just have a quick recap of what all we have learned.
Manorama Horizon, learning made simple.